Differential and integral calculus. In a line function, we can observe the slope of the line. It is used to determine the steepness of a line. Here, we have a line that is slightly rising. And this line is rising sharply. We can measure the slope using the rise over run, or the change in y over the change in x. And this is uniform or constant all throughout the line. But this is not the case for a curve, because it changes. In some part of the curve it is slightly rising. In the other part of the curve it is rising sharply. In order to get the slope at a given point, you have to make the change in x approaching 0. The slope of the curve at this point is taken from the slope of the line tangent to the curve at this point. A curve can be wrapped with many tangent lines. This is the concern of differential calculus, the slope of a curve or its rate of change. On the other hand, the concern for integral calculus is the area mostly under the graph, just like this area under the curve. At first, this area can be formed within a rectangle. Then you can cut the rectangle into two pieces. Then you can cut these two rectangles into several pieces. Here you can have a better approximation of the area of the curve by adding the areas of these small rectangles. The best way to find the area of this curve is to cut again this indefinitely until these really fit the curve. This is how to find the area under this curve using integral calculus. We have here the graph of the equation of the line y equals x. If we are going to get the area of the square in which the line y equals x is the diagonal, we can solve this as area A is equal to x times y. But y is equal to x, so A is equal to x times x and x times x is equal to x squared. Since the y equals x is the diagonal for the square in which the diagonal line divides the square into two, so if we want the area under the graph y equals x, then we are going to divide the area of the square by 2, so the area under the line y equals x is equal to 1/2 x squared. Or area of AL is equal to 1/2 x squared. Let's concentrate on the area equals 1/2 x squared. If we take the derivative of the area A, it's equal to the derivative of 1/2 x squared. Using the power rule, the derivative of u to the power or exponent n is equal to n times u to the power or exponent n minus 1. So dA is equal to 2 times 1/2 x to the power 2 minus 1. 2 over 2 is 1, and x to the power 2 minus 1, which is 1, so dA is equal to x to the power 1, or dA is equal to x. But in this case y equals x, so the area below the graph of y equals x, which is 1/2 x squared, is the antiderivative of the equation y equals x, or area A, which is 1/2 x squared, is the integral of y equals x. To find the derivative of u to the power n is equal to n times u to power n minus 1, this is power rule of finding the derivative. In finding the integral or the antiderivative of power, you just add 1 to exponent or power n and divide the function u by n plus 1. Plus c. C is the constant of integration. If we want to find the integral of x, dx, we are going to consider the fact that x has an exponent 1. So its integral is equal to x to the power 1 plus 1, and x is over 1 plus 1. 1 plus 1 is 2, so the integral of x is equal to x squared over 2, or 1/2 x squared plus c.